Hello everyone, today I am going to discuss the second problem of AtCoder regular contest 146, which is plus and end. So we are given an array of n numbers and we can do at most m increment operations in the array, and after doing the operations we can choose k elements from the array such that their bitwise end is maximum. So let's take the first case, 4821248. So our array is of length 4 and the elements of the array is 1 to 48, and we can do at most 8 increment operations, and after doing these 8 increment operations we will choose 2 elements from the array such that their bitwise end is maximum. So we can increment it 6 times, so it will become 10, and if we can increment the last value 2 times it will become 10, and if we take bitwise end of these two our answer will be 10. So let's take these four and check what is happening in bitwise format. So our first value will be 0001. This is 1, and second value will be 0010, third value will be 00100, and the fourth value will be 1000. So after representing them in bitwise format, what we are doing, we are trying to set the fourth bit, because fourth bit is maximum here, so we are trying to set the fourth bit here. So let's check what is the number of operations needed to set the fourth bit in these four numbers. So the total number of operations here will be 7, here will be fourth bit, not 0 1 2, so we can say it is third bit. Okay, so third bit. So for setting the third bit, zeroth bit, one bit, second bit, third bit. So setting for setting the third bit, in the first element we will require 7 operations, 7 increment operations. In the second number it will be 6, and for the third number it will be 4, and the fourth number it will be 0. So we have already one number which has third bit set, so it will obviously be in our list. So our list, or our set obviously contain 8. Now after incrementing this 4 times, this will also become 1000, and we are taking it in our set. So we have already our desired set of two elements 8 comma 8, and the number of operations remaining are 4, because we have just incremented it 4 times. So our new set will be 8 comma 8, and our number of increment operation left is 4, so we'll just incrementing it. So we have already set the third bit, and the our set is desired set is 1000 and 1000. So now we will try to set the second bit. So we'll try to set this bit. So if we try to set this bit, what is the required number of operations? We will require 4 number of operations here and 4 number of operations here. So total number of required operations is 8, but only 4 number of operations are left. So we can't set this bit in the set. So now we will try to set this bit. So for setting this bit, we will require 2 number of operations here, and similarly 2 number of operations here. So total number of operations is 4, and we have 4 operations left. So we can set this bit also. So 8 plus 2, 8 plus 2. So we have no m left, no number of operation left. So our number of set will be 10 comma 10. Okay, 10 comma 10, and our bitwise end will be 10. Okay, got it. So I will show you my solution now, how I am solving this. Uh, so let's go to my solution. So I am just iterating from the 30th bit, because here the maximum set bit is 4, so we are iterating from fourth bit, third bit, sorry. But our constant is 2 to the power 30, so we are just iterating from the 30th bit. Now we are checking if the current bit is set. Let's say there are 10 numbers. There are 10 numbers, and among these 10 numbers, let's say k equals to 5. So among these 10 number, let's say 3 of them has the 30 bit set. Okay, so we'll just pick these 3 values and put it into one set. Okay, so let's say these are x1 comma x2 comma x3. Now remaining there are 7 elements, remaining 7 elements are there. Now we will take another array. I am taking another array v. Okay, I am taking another array v, and what I am putting here, let's say these are x1 x2 x3, and there are another values x4 to x10. So we will check what is the required number of operations. such that we can set the 30th bit in export or 30th bit in extend. So for doing that, I am doing a complex bitwise operation. So now let me explain what I am doing here. So let's say our binary value is 101010 1. Now we want to set, let's say this is 0th bit, 1 bit, 2nd bit, 3rd bit, 4th bit, 5th bit. So we are trying to set the 5th bit into the array, and we want to find what is the required number of operations, minimum number of operations, increment operations, such that we can set this bit into the number. So how we are doing that? So if we set this bit into the array, our required number will be 1 1, and this 5 will be 0. So it will be 1 1 0 0 0 0 0. So if we take the difference between these two, we will get this. So how we can do it in bitwise format, let's say. So uh, how we are doing it? So we are setting the z bit. Z is 5. So we will take 2 to the power 5 minus 1. What will be 2 to the power 5 minus 1? 2 to the power 5 minus 1 will be 1 1 1 1 1. Now if we take not of 2 to the power 5 minus 1, not of 2 to the power 5 minus 1, you obviously know the complement operation. It will be 0 0 1 1 1 1 1. So if we take the not of 2 to the power 5 minus 1, it will be 1 1 0 0 0 0 0. Now if we take the bitwise and between these value, let's say this value is, let's say v, let's say this is x. Now if we take the and between x and bitwise and 2 to the power 5 minus 1, this 5 bit will get unset. So our required value will be 1 0 and 5 zeros. Okay. Now after that, if we take bitwise or between this 1 6 zeros and 2 to the power 5, we'll get 1 1 and 5 zeros. So I think I have explained you what we are doing here. We are doing x and bit complement of 2 to the power j minus 1, and after that getting this operation, we are ORing it with 2 to the power j. So this is the complex bitwise operation I am doing here. So this is we are storing the difference, the required number of operations to set the jth bit into the value. So we are doing the required number of operations we are doing such that the jth bit is set in the AI value. Okay. After doing that, we are sorting all the values of b based on the required number of operations. Now we are checking, like calculating, like p is what? P is k, like the number of elements in the set. Now if the value is already set, we are decrementing the value of p, and we are checking the for the first p values in the v, what is the required number of operations. Okay. And if c is less than equals to m, we are just deleting c from m, decrementing the value of c from m, and we are just incrementing the value of vi1 by vi0. Okay. And here it is the value of new a is the new array, and we are putting a of vi1 in the new array, and we are doing the same operations for j minus 1 bit into the new array. Okay. I hope you got it. So let me explain another thing here. Let's take what is happening. So let's take, there are four values here: 1 1 0 0 0, 1 0 1 0 0 0, and 0 0 0 0 0. So we are checking this value is already set in one element. So let's say k equals to 2. So we only have to take one element. So now the value of p will be 1. So now we are checking that we will only need 8 increment operations to set the value, this bit in the array. So we are just incrementing it by 8 times and storing it into the array. So our new array will be 1 1 0 0 0 and 1 0 0 0 0. This is the value of new a, and we are doing the same operations for the this is fourth bit, and we are doing the same operation for the third bit. So I hope you have got my explanation. If there is any doubt, any kind of doubt, or any problem with the explanation, you can always ask me in the comment section. Please like the video and subscribe to my channel. Thank you.